Hey everyone, welcome back to the channel. This is Rob, and today's video isn't necessarily anything new. I am going back in time to address an issue in a video that I released in 2021 titled How to Configure Dual ISP Failover on a Cisco Router with a Dynamic Public IP Address. So if you haven't seen that video, chances are that this video probably isn't going to apply to you, so feel free to click off. But for everyone else, you might want to see this. At this point, I'm assuming you're expecting me to elaborate more on the issue, so let me just pull up a comment really quick that addresses it very well. And the comment reads, thank you very much for this super video. I have one problem. If WAN1 fails, then tracks go down, normally switches to WAN2. If WAN1 works, it normally switches back. But when I disconnect the cable from WAN2 and connect it back, and port gets DHCP address. Also, WAN1 tracks go down and never come back. Switches to WAN2, routing can be a problem. Now, what they mean by this is essentially when the cable is pulled from the interface connected to WAN2, WAN1 never comes back. Now, before I present some solutions to hopefully solve this issue, let me just recap some things. When utilizing multiple ISPs for failover, you need to have some sort of tracking mechanism. This normally consists of an IPSLA monitor, a tracking object, and a default route tied to that tracking object. Essentially, you would configure IPSLA to ping a well-known IP address out there on the internet, and by well-known IP address, I just mean a service that has 5 or 6 nines uptime, like Cloudflare, Google, something like that. Additionally, you want to ensure that those ICMP echo requests being sent by that IPSLA monitor only exit the interface connected to the ISP that you want to track. Obviously, it wouldn't make much sense to allow ICMP echo requests intended to track the state of ISP1 to exit the interface connected to ISP2. Because if this was the case, you wouldn't actually be tracking ISP1 at all. This is when I typically use a route map to policy route the router's control plane traffic to ensure that those ICMP echo requests used to track ISP1 only exit the interface connected to ISP1. The thinking behind this is that if the router doesn't get a response to that ICMP echo request, then ISP1 must be down. So switch over to ISP2, right? This method normally works great. However, in this scenario, the DHCP and route map combo is causing an issue. Unlike a typical route map where you would normally define the next hop specifically due to it being statically configured, this route map contains the line set IP next hop dynamic DHCP. So, do you see the issue? When WAN2 obtains new addressing via DHCP, the route map no longer works as intended. The next hop that we only wanted to be for ISP1 then becomes the next hop on ISP2's network, and it breaks the whole thing. Now, I'm going to be honest with you really quick. I do really kind of think this is my fault because I should have thought this through a little bit more when I created the original video. So it was definitely an oversight. Moving forward, I think I have found a solution which involves some scripting using the embedded event manager. Now don't worry, I know that might sound a little scary, but it's not. I have some sample scripts for you to use, and you can modify them as they need to be to fit your environment. It's not the best solution to the problem, but it does work. All right, with that being said, let's go ahead and jump over to GNS3 and take a look at the topology. All right, so even though I used physical equipment in the original video, I did my very best to replicate everything exactly the same here in GNS3. The only thing that might be different are the interfaces that connect our router right here to ISP1 and ISP2. So if you look, you will see that our router is connected to ISP1 via gigabit 0/1, and it is connected to ISP2 via gigabit 0/2. Now, the IP address we're going to be given from ISP1 via DHCP is going to start with 47.35.99. And then with ISP2, it'll start with 60.192.55. I also have this virtual PC down here. I just put that there just in case. I don't think we're actually going to use it, though. I think we're going to focus mainly on the router right here. So with that being said, let's go ahead and open up our console window. And I think the very first thing I'm going to do here is, well, probably change the font on this window for starters. Anyway, so here we are in the console for our router right here. And let's just really quick look and see what our default route points to right now. All right, so we're on ISP1. So you see the static route, our default, pointing to 47.35.99.1 via gigabit Ethernet 0/1. So that's pointing to ISP1. Let me just go ahead and make sure I can ping out to the internet. We'll just do 1111 and 100% success. Okay, so let me just do a normal failover really quick. So what I'll do is I'll just right-click ISP1 and I will suspend it, which will simulate an outage. We'll go back over here to the console. And any second here, we should see that, and there we go, that IPSLA go down, and then our tracking object will go down, which is tied to this route right here. And we will see that the new default is going to point to ISP2 for the next hop. So if I issue the show IP route command one more time, we'll see that that is true. So now we're on ISP2. Make sure we can ping out to the internet, and we can. Let's go back and simulate ISP1 coming back up. And it looks like the tracking object already came back up. So we should see the default route pointing to ISP1 once again in the routing table, and we do. So regular failover works pretty good. And the same thing would be true if we suspended ISP2 and then brought it back up. Although there's no tracking object or IPSLA for ISP2, I just wanted to show you that ISP2 simply going down isn't going to cause any issues. As you see, we're still on ISP1. Now, to get to the meat and potatoes here, let's go ahead and simulate pulling the cable from gigabit 02, which would essentially unplug ISP2 from our router, and then let's see what happens. I'll simulate that by just simply going into interface configuration mode on gigabit 0/2 and shutting it down. And then I'll perform a no shut. And so what's going to happen is once the interface comes back up, it is going to request another IP address via DHCP, which ISP2 is gladly going to give it. And that's going to mess up our route map with that line that I mentioned earlier, and ISP1 is going to go down and never come back up. Do you see this? Reachability went from up to down. Do show IP route. We are on ISP2. Do show track brief. Our tracking object is down. And just to refresh your memory, if anybody has forgotten how this works, I'll issue the do show run interface gig 0/1 command to show you what we have under gigabit 0/1, which is connected to ISP1. So this tracking object right here that's down, which is tied to the IPSLA monitor that went down, is also tied to the route the default route for ISP1. Now, that route map that I was talking about, let me just go full screen here really quick. Do show route map, and do show access list. So a route map is, which is a primary ISP, it's matching on the access list named rmap underscore PRI underscore ISP. That access list is right here, which is saying, hey, permit ICMP from anything to host 8.8.8.8. Now, if we look at our IPSLA monitor, do show IPSLA summary, we'll see that that is configured to ping 8.8.8.8. So as of right now, we have a route map that is matching on anything going to 8.8.8.8, and the actions we're performing on that are setting the IP next hop, and this is the dynamic DHCP part. Now you see current value is 60.192.55.1. Now this is what I was talking about earlier. When our router grabs an IP address via DHCP from ISP2, it completely breaks our whole route map, and you see that the value is for the next hop is the next hop on ISP2's network. That's why when we shut down that interface for ISP2 and we brought it back up, the route map is now doing this. Even though the interface is set for gigabit 0/1 and then null 0, which basically means if this is not a valid interface, maybe it's shut down or unplugged or something, the next step is just null 0. So that way those packets are just dropped, because you wouldn't want them to go anywhere else anyways, because this is directing the traffic for our IPSLA monitor that's only function is to track the up or down status of ISP1. So at this point, this route map actually wouldn't do anything. It's only because of this command that this route map is actually doing anything. So this command essentially tells the router that this route map up here is only valid for its own control plane traffic. So anyways, let's get on with the solution, and I'll kind of show you where I'm going here with this. So if we go over to gigabit 0/1, which is connected to ISP1 here, and we shut it down, and then immediately perform a no shutdown, our router is going to get an IP address via DHCP from ISP1, and then that route map is going to go back to what it was before. And then we'll have connectivity back. Well, not connectivity, but we'll have our default route back in the routing table pointing to ISP1. So you see that we were assigned the IP address 47.35.99.3, and then here we go. IPSLA1 is back up. Do show IP route, and there we go. Everything's good. Do show route map. Now we see that this is pointed to ISP1 for the next hop. And that's what gave me the idea to use EEM scripting to automate this. So this is what I came up with. Now, if you guys choose to use this, you're obviously going to have to modify it to fit your configuration. But what I have here is, get Notepad to drag over. All right, so I have two EEM scripts right here that I made. One of them automates the shutting down and then bringing back up our gig 0/1 interface, and the other one just deletes the route map and then recreates it. They both seem to work the same. I just wanted to put some options out there. So let's just take a look at the first one really quick. I just named it shut, no shut, gigabit 0/1. And we're looking for this right here. So we're looking for a syslog pattern. So if anything pops up in the logs that ever starts with interface gigabit 0/2 assigned DHCP address, that's going to trigger this script to run. Now, this is one of those things that you're going to change if you choose to use this in your setup. So you'd obviously want to change this to whatever interface on your router is connected to your ISP2. Once this runs, after it's triggered by the syslog pattern, we are going to end up in global configuration mode on the router. It's going to go into interface configuration mode for gig 0/1, and it's going to perform a shutdown and then a no shutdown on the interface, like I just showed you, and then it's just going to exit. So this will automate, obviously, shutting down and then bringing back up that interface, which will fix the route map issue. I can just take this, essentially, and copy and paste it in here. I'll go back to interface gig 0/2, again, for ISP2 here. And we'll do the same thing. Do a shutdown. No shutdown. So again, we're just simulating unplugging the cable between the router and ISP2. And remember last time, the IPSLA monitor went down. But we see this time, let me go full screen again here. EEM shut, no shut, gig 0/1 just ran. So now, even though this went down, and it'll only be for a brief moment, we see that the interface connected to ISP1 just came back up, and we were assigned, see, interface gigabit 0/1 assigned DHCP address 47.35.99.4, and then boom, our IPSLA monitor comes right back up. Do show IP route, and we are still on ISP1. Now, the only bad thing about this is it obviously will cause a minor interruption, but I guess it depends on how critical internet service being up every second is for you in your home or in your organization. So this might not be the best solution, but like I just showed, it does work. And with that being said, let me move on to EEM script number 2. First, let me get rid of the one that I just configured on there. So we'll do a no event manager applet, shut, no shut, gig 0/1. And we'll go with this one right here. So essentially, this one, we're looking out for the same thing for the syslog pattern. If gigabit Ethernet 0/2 connected to ISP2 receives an IP address via DHCP, that's going to trigger this to run, and it's essentially going to delete the route map and then just recreate the route map again, which should at that point just point to gigabit 0/1 and then the next hop assigned by ISP1. So let's go ahead and give this a try and see how that works compared to the other one. All right, so we configured the embedded event manager applet. Let's go back to gig 0/2 for ISP2. Once again, we'll do a shutdown and then a no shutdown. All right, so as soon as we get that IP address from ISP2, it's going to run the script, and it did. EEM refresh RMAP. Do show route map. And here we go, current value 47.35.99.1. So we're still pointed to ISP1 for this route map that applies to our IPSLA monitor. Do show IP route. And we're still on ISP1. Now, the difference between the two, I'm sure you noticed, this seems to be a bit faster. Whereas this one right here, shutting down the interface on gig 0/1 and bringing it back up and waiting for it to obtain another IP address does take a little longer. The only thing with this one is I'm not sure. I mean, every time I've tested it, it's worked consistently. I just haven't tested it in the long term, you know, for days, weeks, that sort of thing. There's also the other thing that I mentioned with this first one. Make sure you change the interfaces to correspond to the interfaces that are valid for those ISPs in your configuration. So I can't emphasize that enough. Anyways, that's pretty much it. Like I said, I know it's not the perfect solution, but it works. And honestly, I think that I may have botched the original tutorial a little bit because I don't actually think that what I was showing you guys was actually meant for two providers that are both providing your IP addressing via DHCP. I think what it was really meant for was if you have like one provider and you get your IP addressing via DHCP and the other one, it's statically configured. And if you think about it that way, it would be impossible for that route map to get mixed up because it would only be getting a DHCP assigned IP address from one ISP. So you wouldn't have to worry about any of this. Oh, and with that being said, one other option, I'll have to see if it's in the comments. It may have been a personal email conversation. I can't remember. I'll see if I can find it. But either way, just to give you the cliff notes on it really quick. Somebody did let me know that they resolved this issue by placing another router in front of one of the ISPs. So that way they could statically configure that information. I'm not sure if they were doing double NAT, which I don't recommend, or if they were if they set up the routing correctly. But just food for thought. That's another way that you could mitigate this issue is by placing another router in front of one of the ISPs. And I know it's another piece of equipment, but hey, in a pinch, that would also work. Anyways, thanks for taking the time to watch this video. I appreciate it. Any questions, as always, leave a comment in the comment section below. You can also send me an email if you'd like, rob@rmtechcentral.com. If you enjoyed the video, please subscribe to the channel. I would appreciate it. Like this video if you liked it. Of course, dislike it if you didn't. And I'll see you in the next one.